Let's talk about complex numbers. So previously we've never been able to take a square root of a negative number before, but let's say I now want to start talking about those things and I want to take the square root of -1. I'm going to define that to be what I call I. So I by definition is the square root of -1. If you square both sides of that equation, get the square root of -1 squared, the square and the square root cancel out, and I get -1 is equal to I squared. So I is the number when you square it, it's negative. We've never had this before, and I is by definition the square root of -1. So we can start to talk about complex numbers, which will always look like the following form: a plus b times I, where a and b are real. So real numbers are all the numbers you've known up until this point where we introduced I. So real numbers, for example, are 1, 2/3, pi, square root of 2, all those are real numbers. As long as there's not an I involved, you're talking about a real number. As soon as you allow I, you're talking about complex numbers. So something like 2 plus 3I is a complex number where we say the 2 is the real part, or in other words, the A is the real part, and the B is what we call the imaginary part, which for 2 plus 3I, the B, or the imaginary part, is 3. So that's a complex number. Once you have complex numbers, you can do things with them. Like, for example, you can add complex numbers. So let's say you take 2 plus 3I, and I would like to add that to, let's say, 4 minus 6I. Well, you're just going to combine like things. So we're going to have a 2 plus 4, and we're also going to have a 3I plus a negative 6I. And you can think of that I kind of like a variable when you combine them. So the 2 plus 4, those don't have I, so that's 6. And then the 3I minus the 6I ends up being a minus 3I. So that's addition of complex numbers. You can also subtract those complex numbers. Let's just use those same two complex numbers, except this time I'm going to subtract them, and I'm going to put some parentheses around the 4 minus 6I to really emphasize that 4 minus 6I is a single complex number. So you can distribute that minus. So this is a 2 plus 3I minus 4, and then minus a minus becomes a plus 6I. Combine like terms again. The real parts are the 2 and the minus 4. So 2 minus 4 is a minus 2. And then plus 3I plus 6I gives me a plus 9I. So negative 2 plus 9I is what I get when I subtract them. You can multiply complex numbers together. So let's say I had 1 plus 3I, and I want to multiply by the complex number 2 minus 5I. Well, you're just going to FOIL out like you're used to doing. Say if you had 1 plus 3x times 2 minus 5x, this is going to work the same with complex numbers. So I'll have a 1 times 2, that gives me 2, and then I'll take a 1 times a negative 5I, that gives me a minus 5I, and then I'll take a 3I times 2, that gives me a plus 6I, and then for the last one, I'll do 3I times a negative 5I. So I have 3 times a negative 5 is negative 15, and then an I times an I is I squared. If I start combining things, 2 is the only obviously real one there, and then I have a minus 6I, excuse me, a minus 5I plus 6I. That gives me a plus 1I, and usually we just write that as plus I. And then minus 15, but I have I squared. I squared, we had mentioned up top, was the same as negative 1. So this is 2 plus I, and then minus times a minus is a plus, which gives me plus 15. 2 plus 15 is 17, and then plus I. Division of complex numbers looks like the following. So let's try, how about division? We're going to go with 5 plus 2I, and we're going to divide by 1 minus 6I. Now my goal in the end is to make it look like a plus bi, which means I don't really have a denominator, and I particularly don't have denominators with I in them. So I got to do something clever to get that out of the denominator. And the clever thing that it's going to be is we're going to multiply top and bottom by the conjugate of the denominator. So a complex conjugate is just whatever complex number you're looking at, you change the sign on the imaginary part. My imaginary part for this complex number is -6. So I'm going to turn that to a +6. And if I do something to the denominator, I also have to do it to the numerator. So this 1 plus 6i over 1 plus 6i is really just multiplying by a 1. So now I've turned my problem into multiplication, and I'm going to FOIL at the top, so I get 5 times 1, that's 5, plus 5 times 6i, that's 30i, plus 2i times 1, that's plus 2i, plus 2i times 6i, that'll be plus 12i squared. FOIL at the denominator, I get a 1 times 1, that's 1, plus a 1 times 6i, that's 6i, and then a -6i times 1, that's -6i, and a -6i times 6i is a -36i squared. If I start combining like terms in the numerator, I have a 5 plus 32i plus 12 times I squared is -1. And then in the denominator, you have a 1. And then check this out. The plus 6i and the minus 6i go away. They cancel each other out to 0i. And I have minus 36, and I squared is -1. So you can see I've gotten rid of the I down in the denominator, which is the whole reason we multiplied by the complex conjugate of the denominator. Simplifying still up in the numerator, I have 5 plus 32i minus 12, and the denominator is 1 plus 36, which gives me 5 minus 12 is a -7 plus 32i over 37. It's so close to looking like a complex number, so if we just break that fraction up, -7 over 37 plus 32 over 37i, we can see that finally looks like some number plus some number times I.